Hello, I'm Matthew Malunik. I'm the lead programmer for team 2539, and this is day 6 of our off-season programming workshop. So today we're going to be going over programming CTRE Swerve Drive. So we're going to talk a little bit about Swerve Drive in general, and after that we're going to move on to specifically how we do our Swerve, which at the moment we've varied a bit in the past. We use just the CTRE Tuner X Swerve Drive generator. So let's jump right in. So welcome to day 6. Thank you for coming back. It's our final day. If you've been here for the past 5 days, that's wonderful. If not, those videos are posted on our YouTube channel, so you can go back and see those. Final day, Swerve. So Swerve Drive. Earlier, we went over Tank Drive. This is Swerve Drive. What's the difference, really? So Swerve Drive, usually instead of having 2 sets of wheels on either side of your robot, let me get my laser pointer out real quick. So usually in Tank Drive, you would have like 1 set of wheels here, 1 set of wheels here, all facing the same direction. And your robot can move forwards and turn, but it can't go side to side, which is kind of puts your robot at a bit of a disadvantage because you have this whole direction you can't move in very easily without turning. So Swerve Drive instead has, technically, it needs to be at least 2 modules, but most of the times you'll see 4, 1 on each corner of the robot. But you have a certain number of Swerve modules. And each of these modules, it can basically, it's a single wheel, it can move as fast as you want, and it can also turn by itself independently of the other wheels. And this gives you some pretty cool abilities, like the ability to turn completely independent of which direction you're driving. It allows you to drive in a direction that's oriented relative to the field a lot more easily than if you're using Tank Drive. So it gives you a lot of benefits in competitive robotics. Additionally, you can do some other things, like you can make your wheels turn into an X if you have 4 wheels, for example, and that makes it pretty hard to push your robot if you needed to like not slip for some reason. This is our off-season Swerve example bot that we made last year, I believe. We actually use it as our off-season bot. Right now, it's kind of disassembled, so we're actually going to be programming on our main robot today, but we'll continue. So today, we're going to be using the CTRE Swerve generator, and this is a snapshot from that. To get the CTR Swerve generator, specifically, you need to meet some requirements, which we'll go over on the next page. If you don't meet those requirements, the recommended alternative is something called YAG-SL, so YAG-SL. I will just type that in the chat right now so you can have access to that. Basically, YAG-SL would be the recommended alternative if not all the products on your robot, at least that you're using for Swerve, are compatible with across-the-road electronics. So, but we're not going to be going into that today. So the requirements you need is basically you need to have at least 8 Talon FX devices, basically 4 for your drive motors, 4 for your turning motors, 4 CAN coders, and 1 pigeon. All your devices need to appear in Tuner X, which we'll go over. All of them need to be on the same CAN bus. All your firmware needs to be up to date. You need to be running 24 or newer diagnostics, which kind of happens automatically. There's a little button you can press to start them. It comes with Tuner X, basically. All your devices should be renamed. That's recommended. It just makes it a lot easier to figure out which motors are which. All the devices, it would be good if they're on a carnivore. That's not necessary. And this pro licensed thing, it's recommended, but it's mostly just recommended because they get money if you buy the pro license. You really don't need it at all. Carnivore is actually probably a good thing to be recommended because it can help free up CAN space. So you're not running into issues where you're sending too much information to the motors, basically. So we will pretty much go over this in the lab, which is like any second now, because there's not really much more to it than this. But to use the CTRE Swerve generator, you connect to your robot. You open Phoenix Tuner X, you go into the mechanisms page, choose Swerve Project Generator, and you follow the instructions that it gives you, and it should work. We'll be going over that. So I keep saying Phoenix Tuner X or Tuner X. What is that? Basically, that is a little application, which I will demonstrate now. This computer already has it installed, but Tuner X, right there. The way you get it is you go into the Windows App Store. One second. You go into Microsoft Store. My bad for not being able to remember that. So Microsoft Store, and you look up Tuner X, and you wait. And it should be like the first result. It should look like this. It should say CTR Electronics, Phoenix Tuner X by CTR Electronics, average rating of 3.7 stars. And you should install that. It'll automatically update it if you install it this way. And I do not believe there's another way to get access to it. I'm also not certain if it's supported on Mac. I think it is not. Maybe someday there will be support, but right now there is not. So after that, the way to open it is you just search Tuner X, and you can like drag it to your hotbar, but we're just going to open it. And we're just going to go over a quick tour of it. So up here, you're going to get a warning, and unless it applies to you, you shouldn't have to worry about it really. And it's going to say no devices detected, failed to connect to this. And for that, that is basically if you're connecting to your robot via a RoboRio USB. So if you're using the USB-A to USB-B cable, theoretically we have one around here. Right here. So one end looks like this. This is the end you plug into your RoboRio. Other end looks like this. And if you plug in this way, this is why I think you're going to need this. If you plug in with this, you're going to use, it's going to try using this address. We're going to be using the Ethernet port on the radio to connect. So basically, in this left panel, you're going to see a lot of things. The main thing you're going to want to focus on is this enter team number or IP. And you can choose RoboRio USB, which is the USB cable. You can choose localhost, which I'm not exactly sure why you would end up using this, possibly for simulation purposes. And then there's driver station, which goes off of the driver station if you have the driver station on your computer and are connected via that. And then you can also just blatantly type in your team number. So ours would be 2539. Then it tries connecting to that. And as you can see, we don't have anything there. Okay, but we're going to be connecting via this USB-B cable. And so right now it's failing to connect, specifically because the robot is not turned on. It should be turned on any second now, as soon as we find the power buttons. So we'll just give that a second. If you guys have any questions yet, you can ask them. This should be a relatively short lab compared to the previous videos. So as you can see, we successfully connected to this random number, but we failed to connect to diagnostics. Now, the reason for this is because the robot has not finished booting up yet, to my knowledge. So if you deploy any code to a RoboRio that is running any Phoenix products, when it starts, the diagnostic server should turn on. So I just got a little sound there, a lot of chirps that would make me think that the diagnostic server had started, and it did. If you weren't getting something like that, what you would do is you would press the start temporary diagnostic server, and it should start that temporary diagnostic server and connect to it. Once you're connected, I'm going to press hide because I don't think we have one of those. Where you're going to see a ton of devices, right? And basically, this is all the CTRE devices that you have on your robot right now. So we have some Krakens. We're running Krakens for our drive motors. We have our steer motors. We have our shooter motors, shooter pivot, intake, some transfer motors, some CAN coders. These are important. A pigeon for our gyroscope, and a candle. And as you can see, they're all up to date on firmware. That's what the green means. If they were yellow, it would mean that they're not at the most recent version, and you should update them when you get the chance. You should probably look into updating them anyway. If they're red, that's bad. That means you like really need to update them. So this little outline here is the thing that changes color.
What's different between right rear drive and like front drive?
So for our modules, right, they all look the same, but we gave them different names. And for our naming convention system, at least, the front of the robot is where the intake is. And left versus right is if the robot's like facing forwards, left motors are on the left, right motors are on the right.
What's the licensing?
And the licensing version that we have is Phoenix Pro. You don't need Phoenix Pro. It's very interesting.
That can cause problems. So if you're gonna go pro, then you need to make sure they're all pro. If you're not, then it's okay. We don't get pro, but specifically on turn mode, that's a problem.
Yeah. So on licensing, if you do go pro mode, I know they have a few different ways to buy licensing. They recommend that you basically buy it for all your motors. Really, you more just need pro on your turning is what we have found. If you don't have pro on all your drive motors, you're not really going to run into too many issues. So we don't actually have pro licensing on all of our drive motors. But anyway, this shows you all your motors. If you need to do something with them, you can click on one. It'll give you a ton of settings. This isn't super important at the moment. What is kind of important is this other page just shows you all canopores you have. It appears there is a firmware update available for this. We're not going to go through with that right now. You have device history, which shows you all the times any device is connected to your computer. And then really important is mechanisms. We're going to use that. And then there's some other stuff here. So mechanisms. The only mechanism that they have right now is the Swerve generator. So you can click on that or not. It doesn't matter. This is where you'll end up. And it has this pre-check, which basically checks that you have at least 8 Talon FXs, specifically your drive and turn motors, right? And Talon FX at the moment would be Falcon 500s or Kraken X60s. I don't think there are any other Talon FX motors. There, you need to have 4 CAN coders, which are basically encoders for measuring the rotation of your wheel that use a little magnet to do that. They're very accurate and they go over CAN. And they're sold by CTRE too. So, there's the Pigeon. You need one Pigeon 2.0. And basically that measures the angle of your robot. It's not like it's like the Navex, but then again, sold by CTRE. And it goes, you can mount it wherever you want on the robot. That's something else pretty useful about that. The Navex, you need to plug in like basically on the Robo Rio for the most part. And if it's not flat, you start running into issues. The Pigeon you can put pretty much anywhere. It's just recommended to be low down around center on the robot. But you can like put it sideways or like at an angle. That's fine. And also your server version needs to be 2024 or greater, which basically just means either you deployed from robot code that was using 2024 stuff, which likely your robot has been deployed to, or if this is like a fresh Robo Rio, you pressed the start server button. If you didn't have a, what's it called? A diagnostic server detected. So wheel radius, you just put in the wheel radius of your wheels. Ours is 2 inches because our wheels have a 4-inch diameter. Front left to front right distance for our robot is about 24 inches. And our module type, here you just choose from a drop down of your modules. We are using SDS MK4s. If you're using WCP, they have that as well. And also, there is the custom option, and that allows you to put in any 2 gear ratios. Really, all it cares about is the gear ratios that your module is using. So if it's not supported yet, just enter the gear ratios you find. But we're going to do MK4, and then we can choose any of their gearing options that they officially support. We are running L4s, so we're going to choose that one. And we're going to create a new project. So this is the front of the robot, selected module, front left, right? We're going to choose, in our terms, that is left front. And we choose our left front can coder. For turning motors, we're going to choose left front steer. And for the drive motor, left front drive. So now this Swerve module has been somewhat configured, right? Something you can do is you can press this blink button, which makes tiny light on the device flash. Pretty much whichever light it uses to flash will flash. And you can look at your module and make sure, okay, this is the right one. We got the name right. It's in the right spot, that sort of thing. So you can also blink them that way. That's pretty useful if like your motors aren't named or if you aren't certain you named them right. Or maybe you're swapping out motors really fast. So then you choose the next one and you kind of just continue the sequence. So front right, right front steer, right front drive. Then back left. So for us, that would be left rear, left rear steer, left rear drive. And we have one more motor to do this with, right rear. So right rear can coder, right rear steer, right rear drive. So the way it has you validate your configuration is basically you press this validate configuration and it individually one second. Let me just see. Basically, you press this button and it should validate that the what is it called? Sorry, that the can coder and the Talon FX share the same module. And you need to have your driver station open to be able to do this. Basically, you need to enable the robot. So I'm going to open up this driver station right here. And hopefully it'll open up shortly.
It wasn't touching.
So it might take a while for your driver station to open. Here we have our driver station.
It's coming. It'll play itself.
And we need to choose a team number as soon as it, okay, there we go, loads. Actually, we don't because we're connected via USB, but we have communication. We're all good. We are able to enable. So what we're going to do is enable. And then we're going to validate our configuration. So start the azimuth test. Right now, I'll see if we can get a better view of this. Right. I think that's a fine-ish view, right? But we had our Swerve module down. I guess you can't see that one. So this one, okay, I think it might be slightly off screen, but was rotating. We can do it again just to demonstrate. Okay, I disabled since then, but make sure you're enabled. Start the test, and it should spin around. 1 second. I'm getting like a bit of lag for some reason. So, okay, take 2, basically. If you make sure your drive station is enabled, go into this, start azimuth test, continue. Okay, that time it works. That checks out, and then we validate the drive motor. And basically, we just make sure that that motor is moving. And it is, and that is our front left motor. So validation of this wheel is complete. And so we can move to our other wheels to also validate those. So we're going to validate this one's configuration. And as you can see, this module up here is rotating now. And we can validate the drive test. And it's also rotating. So
you show on the bottom left the incomplete modules list. That actually goes there.
yeah, so there's also an incomplete modules list, which shows you which modules are incomplete. For us right now, it's going to be all of them because we also haven't done the final step of configuring the offsets, but we're going to do that last once we have all our modules validated. It requires you validate your module before you're allowed to complete the offset for some reason. But yeah, so right now we have this module farthest in the back being validated, our back left module. And it's spinning now. So finally, we're going to do our last module, which we have not checked. Theoretically, if you chose a motor that was not on the same CAN coder as the motor, like the CAN coder wasn't attached to the motor properly or was on a different motor, this first step would give you an error. And when validating your drive motor, if the module that you want to spin is not spinning, then you should change your motor, basically. So we've successfully validated each of the Swerve modules. Next, we're going to want to configure offsets. So let's make this full screen. You can disable now. You don't need to be enabled for this process. We have not done this before. So basically, first you rotate your module so that the wheels are forward and the bevel gears are inside of the robot. So for us, forward is facing the intake. So we're going to rotate all of our modules to be facing this way. And we're going to want sure that these little black parts, the gears, the bevel gears, are facing the inside of the robot. So these ones are facing this way. These ones are facing this way. Then you have a few options. Either you can place some screws through these like holes, and they'll go through your gears, and that'll very accurately line up your modules very, very precisely. On our robot, we actually can't do that because we kind of have it blocked off. So our modules also don't have those. So the holes are blocked off. But like the holes in the gear are blocked off by the module. But you can use a just like beam like this instead as the alternate. And you line up that against your wheels and kind of push it against your wheels just to make sure that they're straight. And then you go to the other side. If you're able to do this on the metal of the wheel, that's more accurate. But you can kind of do it on the rubber. Once you have a pretty good lineup, and I mean, the more accurate you are with this step, the better it's going to drive. The better your robot's going to drive. But once you get an accurate-ish lineup there, you press next, and then you can just do calibrate encoder. And then it should calibrate it. And it'll also tell you what the offset is. This number right here is pretty useful if, say, you change a module, like you swap out a module during a competition, and you need to just go into the code and manually edit the offset. You can copy that instead of regenerating a whole Swerve project. You can take a picture of that too. That works pretty well. So I'm finished. This Swerve module, as you can see, is no longer yellow. It's completely calibrated. So then for the others, we're just going to say, I've done this before, start calibration, because we already lined up all the modules properly. So here we're going to configure our offset. And here we're finally going to configure our last offset. Now, Swerve configuration complete, go to Swerve calibration. So we're going to continue, make sure that they're all set to their factory default settings. And there's two things, verify steer and verify drive. So your two options are to ensure that the chassis is placed on blocks, or you could turn your robot sideways like we're doing here so you can easily see the wheels. And you need to be enabled driver station wise. So I'm going to enable the robot. We are enabled. And I'm going to verify steer. What this is going to do is it's just going to turn the modules. So I'm going to press start. And as you can see, all the modules are turning in sync with each other. And they all appeared to rotate from the top. They were all rotating this way, which from an upwards perspective, if you kind of imagine putting the robot on blocks, is counterclockwise. So they all rotated counterclockwise. If they rotated counterclockwise, if like one of them rotated counterclockwise or half of them did or all of them did, you would need to invert those. We don't need to. It's all good. So then we can go back to verification drive. And basically this one is going to make sure all your wheels are straight. And then it's going to make sure that your robot will drive forwards. So we're going to start this and try paying attention to the modules. Once it zeroes them. Yeah, thank you for telling me I was muted there. Sorry. We'll just kind of review that. Basically, generate project once you have your stuff verified. You put in your team number and you would press OK. And it'll ask you for a folder. We're going to choose off-season Swerve demo. And this is going to be the name of the folder that you want to actually have your robot project be in. So it's going to like put Cradle and stuff in there. So in this case, we're going to want to make a new folder, off-season demo 2024. and we're going to select that, and it's going to put a ton of code in there. And you have a few things you can do. It says you should characterize your gains, you should calibrate your pigeon, if not mounted flat, and you should review your documentation. We're going to close out of there, open up VS Code. And we're going to open up that project. And theoretically, as long as you have joysticks connected to your driver station, you should be able to just deploy immediately. It basically generates all the code for you. So we're going to want to open this folder. So select folder. And it'll open this all up. Basically, it's just your default robot project shape, but plus a few small extra things. So in Java, we have generated. This is going to contain tuner constants, which basically is all the information that we input in the Swerve generator, plus a few extra things. And then in robot container, it's your normal robot container, but we have these things called Swerve requests. And we also have some example commands for how to get your robot to drive. Basically, this is just a default drive request, and it uses a joystick that we already have. So joystick, joystick, joystick. And it is specifically using like an Xbox controller for this. You can replace these calls here with calls to your joystick of choice, like if you're using flight controller joysticks like we do. But for now, we're just going to keep it as Xbox controller. And then there's a bunch of other constants you can change, like your max speed, your max turn speed. And it has some other pre-existing setup commands for you as demos. So if we press the A button on our joystick, it'll basically put the wheels in X. And if we press the B button, it's going to point the wheels in the direction that our joystick is facing, but it's not going to drive. Also, it shows you how to reset the odometry. This comes built in with odometry, so you don't need to implement that yourself. And it also comes with telemetry. So we're just going to deploy robot code from the project.
That's a shorter one. They're not getting private. If you need to change that on both and flip them out, with different spacing, probably around the 3 weeks for a day. These quick things and have to go and go from that way to the afternoon to maybe 3 pieces. But really, let's just flip that. Maybe close on it.
So this is just the build process, and it's just taking a while because it's really the first build for this project. It's never been built before, so it needs to build and download all the extra files for WPILib and any vendor libraries that are automatically included with this. So our build succeeded, build successful in about 4 minutes. So what we're going to do is we're going to connect with so let me just make sure you guys can still hear me. Can you see me fine? Okay, so you guys can still hear me. I just had to unplug our other screen so we were able to connect our joysticks. But if we go back in here, we should see we now have joysticks. We have, yeah, we have joysticks. The way you check if you have joysticks is here. They should be green. We're going to rescan just to make sure we have all of them. Current what? That's fine. We don't right now, which means that they're either not plugged in properly or
yeah, I only gave you one.
So checking back, pressing rescan, we have all our joysticks now, which is what we need. So we're going to move, yeah, we're going to move this one to top because we're using the dual action joystick, or should be at least, basically common Xbox controller on port 0. So if we enable, and I use my joystick here, if I go forwards, it moves the modules, and if I go backwards, it moves the modules.
You can put it up.
We're going to turn off the robot and then turn it back on real quick because just in case. Basically, something we're seeing is that these wheels are moving backwards and these modules are moving forwards, which is not exactly what you'd expect. And also, when we tried turning, the arm on the robot went up instead of the thing turning. So it may still be running slightly old code. We're just gonna after
Just elevate them up for a second. Just stretch it.
So if we enable again, using our joystick, now that happens, and if we press to turn, let's see, what do we use to turn? Get right X. It appears that isn't quite fully functionally working due to having a different setup for these joysticks than the default. But we are still getting motion, so that is what we want. So we're just going to put the robot on the ground and try moving it around.
Can you flip it aside?
So right now in the code, one thing I think we're having a small issue with is our joysticks basically not actually functioning properly. So right now it's using Command Xbox controller. I'm going to switch these to our joysticks. So private final joystick, and then left joystick, new joystick 0. And then our right joystick. Let me just make sure I'm unmuted. I'm unmuted. And so this will grab joysticks on port 0 and 1. And instead of these velocities it's getting from the Xbox controller, we're going to use our joysticks. So joystick left, and then get dot. Maybe it's left joystick. There we go. Left joystick dot get X, or I guess get Y it should be. Get Y, and then down here we're going to do left joystick dot get X, and then finally down here we're going to do right joystick dot get X. It appears I misspelled right here, so we're just going to fix that. And now this should be using our main joysticks instead of the secondary joystick. So right now we're changing out the radio on our robot. That way we are able to control it via our driver station. Our off-season robot is a little deconstructed right now, and we're just at a comp. So that's why we're not using that. But so we were able to get the robot to move at least. It's not turning yet. Okay. Here's our code. I'm gonna stop sharing the screen as there's nothing really to share left at this point. The code is kind of in the final state it's going to be. But we can look at the robot. So we're going to deploy by plugging into the Robo Rio, where you can plug in. Any second now.
Yeah, it's hard to figure that turn out.
There we go. It looks like a square, but it's not. It does have an orientation. So we're connected. I'm deploying. we're currently at 68%. %, and build successful. So we'll disconnect there, but make sure that it stays in view for you guys. Okay. And now if we enable over here, and I use our joystick, we're able to turn. We're also able to move. So hopefully you guys can see that. Oh, you guys just disappeared from my screen. There you go. But that's the robot. It's turning and driving. If I get our joysticks in the right order, I should be able to drive it a little more easily. So as you can see, it can move left, right, front, well, I guess back and front, and it can also turn. So that's Swerve Drive. That's how we do it on our team, at least. We kind of just use the generator. That is the recommended way of doing it for CTRE products, at least. Yeah, I guess L includes that. In build season, we use the CTRE Swerve generator to generate the base files. That's basically what we do. Yes, I see your question. Sorry, it took a few minutes for me to see it, but yeah. We do something pretty similar to that. Basically, for our main robot, what I like to do is, let me share this screen again. Okay. Whoa, recursion. So basically what I like to do is I like to move tuner constants out of this generated folder. I personally just don't like it being there. But we will use the command Swerve drivetrain as the drive subsystem, and then we'll just add on subsystems as we need them. So we pretty much do just base all of the code off of the generated code. Yeah, so hopefully that answers your question. This kind of serves as the foundation for the code, though for the most part, it is just the base, like command-based framework option, plus the command Swerve drivetrain, the tuner constants, and the telemetry.java. That's really all that you add by using the generator.
Tuner constants, go over where you put those values in if you got to swap.
So tuner constants, just a question from here. If you need to swap out some stuff, the general rundown is steer gains. This has to do with PID for your modules. So like it has P, I, and D. But then there's also KS, which is for static friction, KV, which is feed forward, that has to do with how fast your module is moving, and then KA for acceleration. Usually these default settings are pretty good. This is the stator current at which your wheels start to slip. For most robots, it's going to be way less than this. To theoretically get optimal control, you should basically push your robot, like have your robot against a wall and start driving it until the wheels slip and see what your current is at when the wheels slip. Because current's proportional to torque, and basically that lets you figure out what the static friction of your wheels is, and it limits this so you don't have your wheels slip. These current limits are here for a different reason. So you have your stator current limit, which is basically how much current you're going to allow just generally. And this is a pretty good default. If you allow too much current through, you're going to brown out. Basically, your battery's going to die during your matches. And also you can damage your motors if your current is too high. So if we scroll down a little more, this is some default gear ratio stuff. You have like your pigeon can ID. And then you have a ton of stuff here. So actual important stuff here, front left encoder offset, front right encoder offset. These encoder offsets, this is the number that was displayed when we were doing like the press the button to configure the offset, this number right here. So if you needed to update your code really fast, like in a hurry, and you didn't want to regenerate tuner constants, if you press just generate tuner constants, it just generates this file. But say like you don't even want to do that, you just want to get the number, you can configure, get the number, copy it, put it there, or take a photo, type it in there. And then this, you don't have to worry about that. So most important stuff is right here under front left, front right, back left, back right. Up here for gear ratios. And then up here for PID values and your 2 current limits. Any questions? So for your question about the leaving the slip current A, theoretically, you should update this regularly. If your treads are wearing throughout the season and your wheels are getting more slippery, right, you're going to want to change this number, because what can end up happening is basically the reasoning behind this is for any wheel, any surface actually, basically all surfaces, the friction between it and another thing when it's not moving, the static friction, is going to be at least a bit higher than the friction between them while they are moving. And what that leads to is if you're trying to accelerate as fast as you can and you just go 100% at it, right? And let's say the amount of torque you generate is actually greater than that static friction, you're going to start slipping. And when you're slipping, you're actually accelerating less. So this is basically what is the absolute max we can push it without starting to slip. And that gives you your maximum acceleration. So yes, if your tread wear, if your treads wore during the season, right? If let's say they're like your spiky tread and by the end of the season, it's like as flat as a pancake, you'd probably need to change this number to account for that difference. Yeah, and also you should test this number. You should by like, what is it? The website with the documentation. So CTRE's website, which I should actually include a link to in the chat right now. But that has a lot of information on how to do this stuff. When you're testing, you should do it on comp carpet or as similar to comp carpet as you can find. If you're on like a flat surface like wood or something, you're not going to get an accurate number. Any other questions about this or really anything we've gone over during the programming workshop over the past 3 weeks? So YAG-SL, unfortunately, I think it would be really cool if it was like the CTRE Swerve generator, but unfortunately it's not. It is the best option, and I think it's the easiest option if you're not using all CTRE components. Here's the link for CTRE docs. But YAG-SL, sorry, YAGSL is a Swerve library, so you need to manually program a lot of the components. They have very good documentation on how to do that, but it doesn't come with a graphical user interface or anything like that. So I will post a link to YAGSL real quick. Yeah, so YAGSL though is significantly more flexible. If you wanted to do something with like here's your link for YAGSL. If you wanted to do something with like only 2 Swerve modules or like 5 or something like that, YAGSL might be the way to go. If you don't want to only use CTRE projects, YAGSL is definitely the way to go. The reason we use CTRE is because if you look on the YAGSL website, if you go to the wiki, the first thing they say is that if your Swerve drive only uses Carnivore, Falcon 500s, or Krakens, and Pigeon 2s and camcoders, you should use the Tuner X Swerve drive generator. Just because it's easier to set up. So using YAGSL would be more similar to how we set up Tank Drive than this. Hopefully that answers your question. If you guys don't have any other questions, I think that would be it. So last chance. But thank you for coming to view our workshop. Thank you for coming to the previous sessions. If you did, I think you guys did. And if you're watching, thank you for watching. But this is going to be it. If you have questions, you can reach us in the FMA Discord channel for First Minute Atlantic. And maybe YouTube comments. We might not be checking those, though. So the FMA Discord is the best way to reach out. Or email should work. So also, our website, team2539.com, should be a good resource. But other than that, we're done. So have a good night. There's our business card. But thank you for watching.